Hi, my name is Lion. Today I will be presenting the topic: Is a light a wave or a particle? It has been a historical question about whether light should be a wave or particles. It puzzles scientists for a few decades, as you can see from the timeline. Around the 17th century, Newton concluded that light was a group of particles called corpuscular theory. Newton saw light as a group of extremely small particles that are emitted by a light source and reflected by objects. However, there was no experiment at that time to demonstrate his hypothesis. Around the same time, other scientists saw light as wave because phenomena like diffraction and interference seemed to accept the wave theory of wave. In 1817, Thomas Young set up an experiment called double-slit experiment, which well demonstrated the wave properties of light experimentally. Young used the sunlight to shine through two tiny slits to create two concurrent sources of wave. It is the same as using monochromatic light to pass through two narrow slits, illuminated a screen in a distance. On the screen, a characteristic pattern of bright and arc fringes is observed. And this interference pattern is caused by the superposition of overlapping light waves originating from the two slits. Bright fringes are caused by constructive interference, and the dark fringes are caused by the destructive interference. The pattern resembled water ripples. This interference pattern shows on the screen demonstrated the wave-like property of light. Here's the other phenomena showing the wave-like properties of light, which is diffraction. Here's the other phenomena showing wave-like properties of light, which is refraction. German physicist Heinrich Hertz noticed that when shining a beam of light onto a metal, it caused it to short sparks. He found out different metals requires light of different frequencies for electrons to emit from the metal surface. While increasing the brightness of light produced more electrons, but those electrons are not of higher energies. And increasing a frequency of the light produced electrons with higher energies, but didn't increase the number of electrons emitted. Classical physics theory of light as wave can explain this phenomenon. Albert Einstein postulated that light is bundled up as particles, called photon. He explained that when a photon falls on the surface of a metal, the entire photon's energy transferred to the electrons and causes electron to escape from the metal surface. Part of photon energy is used to remove atom from the metal atom attraction, and the rest of is to give ejected electrokinetic energy. Quantum nature of light give particles property of light. Talk about what exactly is the light, dual nature of light being both wave and particles. In conclusion, When explaining phenomena relating to a light propagation, light is regarded as wave. When explaining phenomena relating to the interaction of matter within absorption or emission of light, light is regarded as particle. Here's the reference list of this video. Thanks for watching.